All right, next up will be Joe Hickey, who's going to talk about CFE 6.6 release. And let's see if we could, is it working?
Well, let's.
We might have traded one technology for
it
another.
works.
Oh, there we go. All
All
right,
right.
take it away, Joe.
Okay, so is this mic working? Can you hear me? Good. All right, so CFE 6.6. This has been a work in progress for a while now. We last released on 6.5, which was June 2016, so it's been like 17 months. But we made it through all the final enhancements, qualification testing. It's been tagged. It's ready to go. Sorry. We'll move this up. Can you hear me? Good? All right. So yes, it's been tagged. Those NASA users who have access to our Git server can get it today. It's on there. But it should hit all the regular public distribution channels soon. I don't know what the time frame is for that, but I would expect within the next week or two. A lot of what's in here, Jonathan has already discussed, so I might skip through some of these major points because the major target areas of this release were expanding the software bus, the number of endpoints beyond 2 to the 11th or 2 to the 12th, depending on how you count it. Improving multi-core support, SMP support, the electronic data sheets, and of course there was a whole bunch of other bug fixes that went in there. So Jonathan already talked about the CCSCS version 2 support, so I won't rehash this, but that's in there. You can enable it with the message format as CCS version 2, and it generally just works. Duplicate of Jonathan's slide, we'll skip that. The impacts, we did test this with a number of apps, and I have personally tested it with a number of apps as well. And as long as applications have used the correct abstractions, being the type name and the macros for reading and writing fields in the header, it generally just works. The biggest risk factor with this when coming from CFE 6.5 to 6.6 were apps that were just using uint16, for instance, to store their message IDs rather than using the correct type. So that's probably the biggest risk factor with this change, but generally things, it wasn't too bad. SMP support. So the focus here was the known thread safety concurrency issue errors. There were a few. Time subsystem, ES subsystem, particularly with the system log. These were areas that weren't sufficiently protected. They had some assumptions on single core, only one thread running at a time, using priority schemes to avoid concurrent access and that type of thing, which of course doesn't work on SMP. So those have all been fixed. They've been replaced with a true exclusion structure, so it should all be SMP safe now. Introducing electronic data sheets. We have EDS files in the CFE 6.6 release now in a descriptive form. So out of the box with CFE 6.6, you get the EDS files. They describe what the software is doing. It also paves the way to have a more prescriptive action with them so that they can become authoritative documents. If you bring in the remainder of the EDS infrastructure and the tools and everything like that, we can generate the header files and actually have the EDS files be authoritative. And if you make a change to the EDS file, it will get propagated into your message structures and into your commands and telemetry automatically. But as I said, right now in CFE 6.6, it's just, trying not to change too much at once. They're more of a descriptive situation where they're just describing what the software is currently doing. There's been a lot of changes that went in to make it more compatible, so you can move toward a generated header and incorporating the tooling in a future version. And part of that is to make sure all the the names are consistent, that we have consistent naming across the EDS and into the source code, and that we're using common patterns for all of our message dispatchers. Those that are familiar with the code might have noticed that in the various subsystems, they all had their unique flavors of the way they process messages. You know, executive services was a little different than event services, and so on and so forth. But we've done a lot of work in CFE 6.6 to make that all the same, follow the same patterns, so that it's now much easier to use generated files and things like that. So as I touched on the naming conventions, we have done a lot of scrubbing to ensure that the names are consistent, that you can translate a name in the EDS to something in the source code, and it's always going to be predictable and it'll be the same. Scope-based macro names, really trying to be clear about all the various configuration macros that we have in CFE. There's mission config, there's platform config type macros. These were kind of convoluted in terms of what it applied to. So we're trying to be really clear now in saying whether a particular configuration is going to apply across an entire mission, across all CPUs, or whether it applies to just a single platform. So the macro names are actually prefixed now with either CFE mission or CFE platform, and that's to really be clear about what it applies to. Another bit of work that went in is to make sure all software bus interface, all the external message definitions, are based only on mission scope. And the reason for that is if you have a large system with multiple CPUs, if you're defining your messages based on a platform config, well, it could be different on some of the other CPUs. The whole point of platform config is you can tune it to that particular processor. So it's important to have your messages at least be consistent, so when it gets shipped from one CPU to another CPU, that CPU will be able to interpret it. So it has to have the same definitions. But we've still left the hooks in place so that you can tune it for a particular platform. So if one CPU only needs 2 tasks, but the main CPU in a project needs 64, you could still have that tuned to the appropriate processor, but the message will at least be a consistent size. Now, of course, this has an impact on backward compatibility. So in CFE 6.6, we did try to mitigate that by preserving all the existing names that had existed in the past. So bringing your apps up from a 6.5 or prior version up to 6.6, they should still compile and run because all of the old names are typedef or pound defined to the new name. So we've given a bridge, so to speak. That bridge is conditionally excluded using a macro, so you can test your code against this modified version by turning on that macro, which will actually remove the bridge, and you'll see if you're using the older names. But the idea is to phase out the old names in a future version. So we have incorporated a bit of a migration path. Not going to break the apps right off the bat. Some other bugs and other enhancements that were done. Alignment of buffers from executive services memory pools. This had been noted a couple times in the past that on certain processors, the buffers you get from a executive service memory pool weren't aligned. Some CPUs, particularly PowerPC, need 8-byte alignment when you're using doubles. So CFE 6.6 has a feature to actually adjust the alignment of the memory pools based on the actual machine requirements. So it basically looks at the compiler and figures out how the compiler is aligning these larger data types and aligns the buffers accordingly. It also introduces a new platform configuration that you can align it to an even stricter memory boundary if you so choose. And the idea is on some CPUs, aligning it to a cache line, for instance, might give improved performance. So we've given you that option to do that. Short format events. Historically, CFE has always supported this notion of a short format event, but it was never really implemented. The intent was to send the event metadata without the actual string. When events are generated, it's something like 16 bytes of metadata plus 100 and some odd bytes of string. So you can save a lot of space by omitting the string and just sending the metadata. But it wasn't actually doing that. It was still sending the full 122 bytes or whatever it ended up being. It just zeroed out the string, or zeroed out the first byte of the string. So it wasn't really gaining you anything. So we have a real implementation of short format events in cFE 6.6. It will actually just send the metadata, the short 12 or 16 bytes or whatever it is. In order to, again, hopefully avoiding breaking apps, there was a risk, obviously, if an application is subscribing to events and it was expecting 100 some odd bytes and now you're only giving it 16, that could be a problem. So the decision was made to actually send the short format events on a different message ID. So if you're subscribing to events, you can continue subscribing to the long format events, and by default, it will be the long format events. And that will be the same size. So this should be backward compatible. So so summary, cFE 6.6, we finalized it. In the release, of course, there's a version description document, and that has much more detail about all the various bug fixes and things that went into it. There are quite a few that I did not talk about, some more bug fixes and things of that nature, but it should help pave the way. I mean, this is just taking steps forward toward EDS, towards some of these other technologies that we're looking at, and I think there's some interest in. So hopefully it's a good release. And any questions about it?
Sure, I got one. Oh, is there somebody? Yeah, I have
So this question has been in my head for a few minutes since you were talking about the multi-core support, but
Yep.
has any discussion occurred in the CCB, or I mean, maybe you and Greg were hashing this stuff out, so I know you did a lot of it, on lock-free synchronization or lock-free design?
Yes, as a matter of fact, that was the time infrastructure. That was part of the problem with that, is that it was actually using a lock-free type approach, but assuming a single processor. And that continues to use a lock-free approach today. The idea being that most CPUs that we envision people using should be able to support that without a problem. One thing that we don't have in the abstraction layer at this point is the concept of a memory fence. So like a read fence and a write fence. The assumption being that on the CPUs we're talking about using, they won't do out-of-order memory access. At some point in the future, if people start to use such a processor, we'll have to...
Well, remember, it's not
Yeah.
just the out-of-order access, it's also the compiler optimization.
Well, the compiler optimization we've handled by anytime anytime one of these atomic values are used for lockless synchronization, it is marked volatile.
Okay.
So the compiler should not optimize it away in the case that you've turned on optimizations, and we've tested that. The cFE 6.6 has been tested, and in particular these particular subsystems, the time and ES subsystem that was a target of the SMP development. I personally did some testing on that with an 8-core processor, with optimizations turned on, and basically did a torture test of an app that literally is set up so that multiple threads are intentionally hitting the same resource at the same time to exercise it, and have verified that it is working correctly. So.
Good. Yeah, I've been worried about this for a while going forward, so it sounds like we're moving in the right direction, and that's really encouraging. So,
Did you write a ticket?
probably not. You don't pay me to write tickets.
Oh.
Or at all.
Are there now guidelines for like the new apps being written for the naming convention? Sorry, going back to naming conventions. Are there?
Yeah, so there is a naming convention document in the repository that describes how the naming convention is designed and how it should look. But basically, it's a everything is qualified with a namespace, which generally had already been done, which was either the name of the app or the name of the subsystem, for instance, CFE-ES, CFE-SB, followed by the actual type or value, and in the case of enumerations, the actual enumerator after that. So it's not too much of a departure from what was already there. It's just made to be now a documented rule or a documented convention that we've scrubbed and made sure everything is now following.
So when you're going through your code walkthrough, you're supposed to check this
You're
list,
supposed
right?
to check it. Right. Yes.
Yeah, on the alignment support for
Yep.
the memory tools, does that help fix the problems with tables and software messages as well, or there's still more we can do?
So the question was with the alignment support for tables and software bus messages, it goes part way. Basically, what it means is every time you get a buffer from the pool, it's going to be aligned consistently, the start of it. You still have the potential for misalignment within your data structure itself. So, for instance, a telemetry packet has a 12-byte header, which is not a multiple of 8. So if you start your telemetry packet with a double, that still could be a problem. The compiler will either introduce padding or you're going to get a misaligned situation. So we haven't solved that. The EDS in a future version can solve that for you. Or in this version, it's still a risk factor. But at least the buffer you get from the pool won't be hit or miss. It's always going to be aligned the same way. Because in the previous version, you might have been on an 8-byte boundary, you might have been on a 4-byte boundary. It was luck of the draw.
Right, no, I'm glad you guys got that in there, thanks.
Yeah. Yes.
Let me get the timeline right. Did you say that the public? Did you say that there we go. Did you say that the public release outside of NASA was 15 months away?
Oh no. 15 months since the
You got me
previous one.
excited, and I
Yeah.
was like, "Excuse me, wait."
No, it should be real soon now. I don't know what other signatures it might need to get shipped off to SourceForge or the public repositories, but it should be soon.
And then for the lock-free stuff, you said that you added volatile.
Oh, that's in there. Yeah, that
Okay.
all shared shared instances of integers or atomic values that are used as synchronization points are marked volatile, at least in the CFE. There are not many. Most of them are already protected by true locks, in which case you don't need that. But in the cases where it was using it as a lockless synchronization mechanism, things are marked volatile, so that you should be safe to turn on your optimization and rest assured that it's not going to get optimized away.
And the compiler and memory barriers are abstracted out as well.
Well, that's the thing that we're still missing is memory barriers. We don't have memory fence abstractions in there yet. So, yeah, if you have a processor where that's an issue, that's still a worker for a future version. Me personally, the only systems I've worked on that have that type of thing are large multi-way, like 128 core cabinet size server machines. So I'd be surprised if a flight CPU has an architecture that would be necessary, but definitely if that comes up, that's something we can work on.
Has there been any consideration of like a portable concept of atomic operations, like increment, test, and set, and things like that?
That would be nice if the C standards even expose that. I mean, as far as I know, any access to that is still a CPU-specific extension type of situation. So
Yeah, so you could stick it in the PSP behind an API, and then even if,
yeah,
If
I-
the processor doesn't support it, you just use a traditional semaphore and it's slow, but that's a caveat for that processor.
Right. I mean, I think there's things that could be done. At this point, I haven't heard the strong need for it. I mean, I think the perspective of the C Standards Committee, ISO, is you should be using locks. Obviously, they're not as concerned about performance as other people are. I think in those really performance critical situations, you could probably go ahead and use the compiler extension, whatever it is. I know GCC has some built-ins to get to that sort of thing. So we don't restrict you from doing that. It's just the abstraction currently isn't there, and I haven't heard. I mean, I think it's another one of those examples that if a lot of people are looking for that sort of thing, maybe we should be adding it to the roadmap. It's not on the roadmap right now. But it's a reason to write a ticket. Write a ticket and get a lot of Me Too's in it, and maybe somebody can fund that. Yeah.
All right, well, thank you. Any other questions?
All right.
Joe?